So basically what I'm going to do is, go over the slides I used for this lecture I did a couple of weeks ago. Because, especially a lot of the younger people, well, not younger, a lot of the newer members may not be familiar with the history of TT Lab, etc., and why we do certain things. And it also gives, some background on some of the other projects we've been doing, because I know many of you work on your particular project or paper, but you may not know some of the other stuff that is going on. So this will give you an idea. Also, the people looking for projects, these are potential starting points. So I will skip some things because this was given to a different audience, so I will modify that only. But I'll talk about the players in data science R&D ecosystem, outline of the model, the TT Lab model in general. Some of the success metrics that I like to monitor. And then I'll talk about some of the publications we've done over the last 6 months to illustrate various aspects of the model. All right, so you all know what data science is on AI. Locally, we need to become more competitive to compete globally. Otherwise, we'll end up in the same situation as in the past, where we would depend on foreign expertise. So the technologies would exist, but we will have to bring in foreign expertise to do certain things that we ourselves could do. So that's one of the reasons for this particular model, to solve real world problems and also to work on societal problems, which we are doing with, for instance, with Cropper. All right, so some of you are familiar with the project we now have with Cropper, where we will be working with 10 civil society organizations to help them collect data and make better use of their data in decision making. So that'll be, working on societal problems. Another purpose of this model, of course, is to take new graduates and give them some real world experience, but also give them some guidance. The way the way things operate right now is students who graduate, some of them, they get internships during the undergrad internship program, which Nicholas and Sharita does a great job at doing. But this is more for research type work. And the reason why we need to look at research type work for industry is because, especially in data science, it involves a lot of creativity and also being able to learn new techniques, new tools, keep abreast of the latest techniques, etc. So it's a more research oriented than maybe software development, which is pretty much more stable. And the model is also to bridge academia with industry, so that both parties benefit. We benefit by working on real problems, getting real data sets that we could work on, and industry benefits from having some of their problems solved, which we've done in the past. So this is you probably heard about the triple helix model, which includes government as well. So it's really government, academia, and industry. It would be nice to have government involved, and I have tried in the past, but you know, it's not as easy to collaborate with government. It was promising, you know, a couple of times, but at one time, Ministry of National Security contacted us to work with us on our project, but when their management changed, then the project got dropped. But ideally, that would be the perfect thing, you know, having, well, they also talk now about a quadruple helix model, which I only heard about recently, which is including civil society. But we are already doing the civil society part, so adding government would be nice, a nice addition. We did propose working with Ministry of Digital Transformation, where we would help supervise their APs, because they are now taking most of the APs, and it's more difficult for us to get APs. So we had proposed, you know, working with their APs on projects, but you know, that hasn't panned out. By the way, feel free to ask questions as we go along. This is very informal. It's not, you know, not a formal thing. So just turn on your mic and ask a question if you have one. So this is the typical model for those of you who haven't, you know, done one of these internships before. So this is typical. It's not always what happens because different companies have different requirements. But typically the student is provided with a monthly stipend of about $10,000 UTT. The intent is to work remotely. Now, why a stipend? Well, for those of you doing in grad school, doing your thesis, etc., in order for you to make some money, you know, you would have to, if you didn't have the stipend, you would have to do other things like being a tutor, etc. So the stipend allows you to be a little bit more independent and not have to work, do other jobs in order to make money. Another reason, though, by the way, is when we first started doing internships, we did it for free. And one thing I realized is that anything you offer somebody for free gets lower priority. Once they are invested financially in the intern, then they give that work higher priority because they pay money. The student is supervised by a faculty member, and typically it's a 6-month period. There's also a supervisor on the company end. You know, hopefully in the future we could get more faculty members doing this. But one of the issues is, right now at least, there's no compensation for the faculty member, right? So I don't get paid, and not everybody would want to do stuff like this for free, because it does take quite a bit of time, you know, working with the company and the student as well. Just a minute here, let me see what happened. All right. So yeah, the idea is to have, you know, a faculty member, student, work on that project. Has to be a non-trivial problem. You know, I've had companies come to me and talk about websites, and I told them, well, no, we don't do websites. We don't do mobile applications. We don't do database stuff. You know, we want to do something that is non-trivial and important to the company. So it has to be non-trivial so we could publish, but it also has to be important to the company so the company benefits, right? All parties need to benefit, otherwise it doesn't work. So we go out, we meet together with the student, would identify a solution that is sufficiently novel for a publication. And this benefits the company because they get a solution that is quantified through analysis, because we try to quantify the benefit of whatever solution we provide. And the student develops a prototype, proof of concept, and publishes. Now, so what's the benefit to the faculty member? Well, that is would be an issue, you know. In my case, it really doesn't matter, but you know, if there's need for financial compensation, then the model has to be updated. Now, talking about models, I was asked to be involved in this project. It's about 2 million euros, called iCamp. And iCamp is essentially doing this, but they have funds now to pay the interns. So the company doesn't pay the interns. The project will pay the interns as well as the faculty member. So that would open up more possibilities. All right, so the benefits to the student, I kind of went over this, but so the student the stipend allows the student to focus on research, no need to do other jobs. It's typically it's part-time. So it's a part-time internship for those in an academic program to allow you to do work on your thesis. The student works on a real-world problem and, you know, gains relevant work experience. And many of you have gone on from being an intern to being a full-time employee because the company recognizes the value you provide. So it allows you to show yourself, and it also allows the company to evaluate interns to decide who they want to keep. So far, the companies have done stuff like this have kept or have made offers to every intern because they saw the benefit that they provided. No, not every intern took up the offer though. So that's another thing. The intern has the ability to see what the company offers and then decide if to take it or not. The student publishes and may use their research for their thesis. So this comes in handy for MSc students. All right, so I've had several MSc students do their thesis under my supervision, get an internship, and use that internship for both financial gain because they get a stipend, they get a publication, and then they use it for their thesis. Of course, the publication is also helpful for people applying for grad school. So several, various people who have gone on to grad school have used their publications in that application process. And as I probably told most of you before, publications or research potential is, for some universities at least, rated very highly. And in some cases, even higher than your grade point average. When I applied for grad school, my grade point average was, I think, like a B plus or something, whereas most of my colleagues had A's, you know, a GPA of A or A plus. And the difference I made, or the reason I got in while some of them didn't, was during summers I did research with different professors, whether it was in satellite stuff or power, and that helped a lot. So put in, you know, research on your application makes a big difference. And of course, if you're just going into the workforce, you know, having this internship experience on a CV now gives you some past experience that that you could use to sell yourself. Benefits to the company, well, the company gets a high quality solution because it's peer reviewed, it's published to a relevant problem. The cost of the solution is significantly less than external consultants and vendors. So some of these companies pay lots of money for, and I guess most of you probably, or some of you already know this, that external consultants cost a lot for these companies, and the solutions they would get from them may not be as good as what the intern could provide. And the cost to the company is basically just stipend, which is negligible. 1 month's worth of a stipend is is probably, you know, a few hours, 2-3 hours worth of external consultant. So big difference. Now the 6-month period only allows us to do up to like a prototype or a proof of concept, but it doesn't give us enough time to do a commercial deployment. And this has been one of the issues we've faced with different companies. Now, in some cases, they would hire the intern and the intern would continue commercial deployment, but this was an issue. So I had mentioned this to a couple of friends. Some of you know, for instance, well, 2 people, Eddie DeVes from, he used to be at Davos, I believe. And the other person is, good grief. What's the guy who used to teach software engineering at UE, the foreign guy from Malta?
Dr. Borg.
Borg, right, yeah. So I was in a seminar once and I mentioned this problem to them and they said, well, all right, let's put together a company to really do additional deployment or further development and deployment of these solutions. And that's how Div Solutions came about. So Div actually hires people full-time. So Jordan and Nicholas were full-time at Div. Well, Jordan is now part-time with Div, working on problems. But if we had a more permanent structure where we could offer long-term maintenance of products, then we could do something like this. But you see, right now, people come in and out of TT Lab, so there's no way to really have some kind of long-term product development and maintenance plan. Now, yeah, just yeah, one minute. Yeah, Jen. Yeah, I will call you back after. Okay, all right. Yeah, so it would be nice to have a better solution to this long-term. I know DSIT has something that it's doing that more long-term development or long-term maintenance of a software, but yeah, we'll have to see how to do that. All right, the company could also evaluate a student to determine if to offer a permanent position. And what they found, and local data scientists are more committed to performing well than foreign consultants. And I could see that as well. A lot of these companies, the consultants they would get may not be the best that the external vendor has to offer, for various reasons. I wouldn't get into it, but yeah. Yeah, Davin. All right, thanks, Nirvan. All right, so benefits. By the way, I assume my slides are changing, right? Because sometimes I have a problem with that.
Yeah.
Yeah, okay. All right, so benefits to the faculty member. So the faculty member will get some practical experience, which you can draw upon in class, because one of the flaws in academia is the fact that some lecturers may not have had any industry experience, and so they cannot they cannot draw upon real world problems when they teach. So this will allow people to actually bring up real world problems in their classrooms and discuss, etc. Minimal time spent on problem identification and modeling. So the faculty member is only supposed to help the student work together with the company to identify the problem, come up with a mathematical model, and the rest is stuff the student should know already, right? So it's applying some techniques, whatever. It may need more of a novel type solution, which I would work with the student on. But the rest should be done by the student. So it shouldn't take too much time. In most cases it doesn't take much of my time, but in some cases it could, depending on the type of problem. There's no financial compensation, but they get a publication and industry exposure. As I said, with this iCamp project funded by EU, they have funds to compensate the faculty member as well. Now, in the past, companies have offered to compensate me, but I prefer either get really full compensation, which would be a lot, or no compensation, rather than something in between. So I prefer not to ask, for what I should really be charging. All right, and then the faculty is able to raise the profile of UE within the public domain. We'll be actually out there in the public doing stuff, and so people wouldn't say that UE is this this closed academic institution, blocked off from the rest of the world. All right, so where do we get these interns? So normally, if somebody comes to me to do research on the TT lab and I interview them, etc., I wouldn't normally put them straight out there as interns, because I like to evaluate them first and make sure they are they are well equipped to do a good job, which is why I keep saying, those of you interested in internships, you really need to do something first before I could really give a good recommendation. And it's not only for internships, but for grad school as well. When you want a recommendation, I will only put down stuff that I could vouch for, your ability. So if you haven't really done anything with me, even if you just took a course from me, all I could put down is you took a course, you did well, that kind of stuff. All right, so TT Lab is really an ad hoc group. It's not any kind of legal entity, which means that when I do have to do MOUs, etc., with companies, I cannot do it with TT Lab because TT Lab is not an entity. So I have to do it with TT Nick. So people may ask, well, why not do it with UE? Let's just say it will take a lot of time to do it through UE. So, and I can give examples where it took months to get it done through UE. All right. So TT Lab will include undergrads, some postgrads. I'm trying to stick more to postgrads now because, I'm finding that some of the undergrads are not doing as much as I would like, unlike some of the past undergrads I had. National scholars, returning scholars, some diaspora, etc. All right, the members are from multiple disciplines, not only data science. We have people in statistics and engineering, etc. Focus is on publishable solutions for real world problems. And right now it's about 25 plus researchers, but this doesn't count alumni, and it doesn't count several MSc students who are doing their thesis under my supervision. I try to keep it at 24. Well, it's 25 plus 24 plus myself, 25. I try to keep it at that number so that I have enough time to spend on each individual. And what you will find is that I don't force people to do stuff, but if I realize that people don't have the time to do stuff, then I kind of rotate them out and bring in new people, right? So it's just really to give opportunities. This is this is the composition of TT Lab. By the way, there's a nice little tool that I use now and then. It's called MatLatex, or I forget the exact name, but it allows you to draw these diagrams, which with a GUI interface with your mouse, and then it converts it into LaTeX. So it allows you to put it in LaTeX in your document. So if later on you want to make any adjustments, like if I wanted to change 25 plus to 30 plus, I could just change it within the LaTeX document. All right, anyway, come back to this. So we have data scientists, computer scientists, electrical engineers, statisticians, mathematics, mechanical engineering, like Kevin, physics, actuarial science. So this is the input. So they come in, they do research. When ready to do internships, they do internships, or they work on grants. So some people are paid through grants like the CIBC grant or the National Geographic grant. Some people just do academic research, like people doing their thesis. And then they get spun out. Some go to grad school, some go out and teach, some go to different companies like insurance, banking, telecoms, big tech, so companies abroad, cybersecurity, energy, etc. So what is interesting is the mix of people within TT Lab. You know, it's a mix of backgrounds and a mix of future interests. Now, unfortunately, with COVID, we haven't been able to mingle as much as I would like. You know, in the past, we did some mingling because we met in person for meetings, etc. But hopefully in the future, we could change that. All right, so this is an example. So this is an example of of a typical model. And as I said, different companies do things differently because, you know, they have different requirements and rules. So TSTT had contacted me and they said, well, they want to develop their data science internally, but what they tried to do is they told they gave their employees the option of taking online courses. So some of their employees with a sufficiently, you know, rigorous background did some data science courses online. And the hope was that they would then be able to transfer that knowledge to work on data science projects. That didn't work out. And the reason is that having the knowledge, the data science knowledge, is insufficient. You need to know how to apply it to real world problems. So then they called me and they asked me for data scientists. They asked me what the internship program was, and I explained to them. They wanted 5 data scientists for 6 months. And as usual, I reached out to people. I was able to get 3 MSc statistics people, 1 MSc in data science, and 1 undergrad. So this was a case where I actually pulled in an undergrad because, you know, we were short on people. And this happens a lot where you know, people ask for interns, but you know, there aren't sufficient people available. So we went in, we worked with 5 different departments on 5 different projects. Each intern worked with an employee in each of these departments on a particular problem. So one was in operations, that was Darren. One was in marketing, that was Navin. One was on pricing, that was Gabrielle. One was on customer service, that was Raphael, and one was on fraud, which was Mariella. All right. So the interesting thing here is, you know, you think about data science, it applies to, you know, most departments within a company. Now, each of them developed either a prototype or a platform. It was a low-cost, high-quality solution. Each project ended up in a publication. And those publications were jointly authored by the employee who helped on the project. Interestingly, one of those employees went off to do his MSc in data science last year. And another one is presently doing his MSc in data science at Georgia Tech. So they kind of got a little, well, I don't know if this internship helped in getting them to do that. All right, so 5 publications. And yeah, as I said, we've had similar things with companies like Sagicor, TN Tech, Massey, Guardian, etc. With Guardian, it's a little bit different. Basically, interns go in, but they within 4 to 6 months, they actually get an offer. All right, and a similar model for data science at Div. All right, so how do we measure success? You know, so we deal with data. Oh, I missed a slide. Right, so funding. How is TTNIC funded or TT Lab funded? Yeah, by the way, TT Lab was supposed to kind of be a kind of interim name. I kind of named it after, there's TTNIC, which is a company I formed years ago. And then TTNIC formed this group, TT Mag, which is a policy development group. And so I just stuck with that and formed TT Lab, but it was supposed to be temporary. But I'll stick with it, I guess. So funding, interns are compensated directly by the company. So, which is why we charge. And as I said, it's typically 10K, but we've had cases where students have been paid 15K. And that was part-time. All right. No compensation for supervision. And I think this is where the company actually benefits the most, right? Through my supervision. Well, I shouldn't say that. I should not benefit the most, but they get this benefit beyond the intern. Yeah, just one moment here. Let me just mute. Yeah, just giving instructions on my on dinner. All right, so you could also get some people are funded through grants, as I said, and I'm hoping this iCamp thing will allow us to do a lot more of these paid internships paid by the grant as opposed to the company. So other grants would be like NGS. In terms of we have this NVIDIA hardware grant where they gave us at first they gave us 1 GPU and we have a server which we presently use, and then we got another grant from them with 2 GPUs, and those were I think those were worth about 4,000 US, if I remember. Shiva could correct me. But
6,000 US for one.
How much?
I think market price now is about 6,000 US for one.
6,000 for one. So that's 12,000 there?
Yeah, that's the GPUs we got, yeah.
Wow. I didn't know that. So yeah, so the GPUs cost 12,000 US. But of course, you have to have the supporting hardware like CPU and memory and storage, and that costs another 8,000 US, which TTNIC sponsored. So we have 20,000 US machine that will be going into the on campus later this week. So thanks to Shiva for doing all the hard work. It was a long process because it took us a while to get approvals as well, customs and all that kind of stuff. So yeah, so we will have a high-end machine sponsored by NVIDIA and TTNIC. TTNIC also, sponsors, well, as I said, hardware, but in the past we did some scholarships as well. If I am correct, I think we sponsored the MSCs for Shiva and two other people, Shiva, I can't remember their names. Who was it again? Anderson and who?
Matthew.
Matthew, right. So, but we haven't done that in a while. And then attendance of conferences. So we, many of you have gone to conferences, sponsored by TTNIC. But with COVID, we stopped, which allowed us to really submit to a lot more conferences than we used to, because when you submit a conference, they only publish the paper if you attend. But because of COVID, we didn't have to attend in person, we could attend online. And so the only cost us was the registration fee, which was still outrageous, 600 US, etc. But it allowed us to be a little bit more flexible with conferences. But it is good to be able to travel to these conferences and meet people. So hopefully we could start that back and have some of you go to some of these nice locations. All right. So metrics for success. So we, of course, with data science, you want to come with a performance metric, right? And there are different ones you could look at. Number of interns requested, because the companies actually reach out to me for interns. I never contacted any company asking, whether they will take interns or not. In each case, they've contacted me and said they've heard about TG Lab, they want to get some interns, etc. So, so that's one measure of success. Number of students provided permanent positions, the intern conversion rate. And as I said before, I think in almost all cases, I think probably there's one case where permanent positions were offered to the interns, although they may not have taken it. Grants and patents. This is something I would like. Well, the grant stuff, the reason I haven't really focused a lot on grants is because of all the paperwork, to be honest. Which is why with the NGS grant, we did it in collaboration with Prof Foundation. So they manage a lot of the paperwork stuff. But with other grants, like with CIBC, which we had to do it through UE, again, Shiva would be able to tell you all the hassle we had getting approvals and stuff like that. So I am sure we are capable of getting a lot more grants if we applied, but it's a lot of paperwork. So in the future, if we need to, yeah, I will reach out and as long as people are willing to take the lead on applying. So in most cases, yeah, like the NGS grant, people like Gabrielle and Keanu took the lead and applying for it, and Mindy. Well, no, Mindy wasn't in the start. For CIBC, Shiva took the lead on that, etc. The final one is peer-reviewed publications and prototypes developed. So you really, I like to look at the peer-reviewed publications because that's a good trade-off between these different metrics. And with respect to that, we have been doing good. We have slowed down quite a bit. I'm not sure what the reason is, but now that classes have ended, I plan to start picking back up. Now, what I'm trying to do is convert to focus more on journals as opposed to conferences. So we will probably have fewer, but more high quality. Although the conferences we submit to are good conferences, either IEEE or ACM. All right, so what I'm going to go through next, and this was more for that presentation I gave. I wanted to let people see, some of these talks, people talk about what can be done, what kind of models should be used, and what are the various ways we could go about doing it. It's always about what can be done, or so what I wanted to highlight here is what has been done. All right, what benefits we've accrued through this model. And of course, it gives me the opportunity to kind of boast about what the work you all have done. So I decided to say, I didn't want to have too many publications. So I said, I'll just focus on the last 6 months. Well, of course, this was 6 months start, based on when I gave this, which was like about 3 weeks ago. But so I looked up the last 6 months, and that was 4 journals and 17 conferences. So it was quite a few still, but I decided to just, kind of go through each, because each has some interesting background. But it also illustrates the benefit of the model, right? The fact that students either end up in a job they like, they end up in grad school, or they continue research and they publish. Also, I want to highlight the fact that it's a wide range of topics we work on, all right? So most of you are interested mostly in data science, but we've done stuff in communications, etc., and also a wide range of domains. So it spans from insurance to banking to telecoms. So that makes it interesting as well. And of course, yeah, kind of reach out to people. We were always interested in collaborating. I still am not sure why people do not collaborate as much as they could, which is unfortunate, because collaboration is the best way to really do good work. So I'll go over these papers. Let me see, time 4:55, 7:55. So I'll quickly go over these papers for those of you not familiar with this work. All right, so starting from the oldest to the newest. So soft churn, optimal switching between prepaid data subscriptions and eSIM on eSIM supported smartphones. So this is work that Gabriella did together with Aviel at TSTT. And as I said, Aviel is now doing his MSc in data science somewhere in the UK. And it was based on the project at TSTT, but not done as part of the project. because what we were really asked is to come up with pricing methods or pricing framework for SIM card, for prepaid accounts. And then when I started looking at the issues involved, I found that, using an eSIM would allow some nice optimization. For those of you not familiar with eSIM, is, most of the newer phones support electronic SIM. So you could have a physical SIM together with, I believe, about 4 eSIMs on your phone, which would allow you to have 5 providers on your plan. So for instance, I use my phone for both TSTT and AT&T, so I could get Trinidad calls as if it was a local call. So this talks about optimizing, which provider to choose. And I mentioned it to Ramnik in Korea, and she was interested in. We had done some work on pricing for wireless communication, for cellular plans. So this was related to that. So we are continuing some of that work on this, applying it now to QoS, which is beyond where we will be in the next few years. But once QoS is available, then how do you do this optimal switching? Personalized overdraft protection method. This was conceived again from CIBC project. It formed the basis for Carisha's MSc. But again, it wasn't something that we could have deployed within CIBC at the time because of the limited access we had. Figure of merit. This is work that Darren did at TSTT together with Danielle. I believe Danielle is doing, and Jade probably could correct me, but doing his MSc in at Georgia Tech remotely. By the way, which is a good option for those of you deciding to do thinking about an MSc. Not to say we, of course we have an MSc at UWI, but we don't have the resources that Georgia Tech would have in terms of a variety of courses, etc.
Daniel, we'll be starting soon, in September, I believe, or later this year.
Okay.
Yeah.
So actually another TT Lab member, past member, Nicholas Jacob, I believe this is his second year in that program. But by the way, for this particular project, the person who requested it stated that the quality was just as good as if they had hired an external vendor to do it. And it was a lot, of course, it was a lot cheaper. That person happens to now be the Minister of Digital Transformation. So hopefully he appreciates the kind of stuff we could do at UWI. All right, so this is these are some of the papers we did based on the NGS project. So these were papers in the UWI conference on tropical food and agriculture systems. So it's preliminary work, but we decided to present some of it. So there's another one. This is Rogansi put together this one, related again to the NGS grant. This one was put together by Mindy And by the way, this first one here, the journal version, which we worked on afterwards, was kind of led by Sarah. So this one also has a journal version in progress. All right, so this is work by Inzamam on his PhD stuff at Asunam, theoretical work. But yeah, one thing I want to bring up is, some of these ideas come up, based on some of the work we do with companies. To really get interested in problems, you really have to look at what companies need. All right, and of course, then you take it and make it more theoretical, more generic, and solve a more mathematical version of it. But the basic idea, optimizing more for the long term. This one is using recurrent neural networks to approximate orientation with accelerometers and magnetometers. So this started quite a while ago, and then Akil dropped out, and then he said he wanted to restart it, and then we continued it. So this is work we did for Nicholas when he was working on his sensor bracelet, his bracelet that had various sensors, etc. This was trying to figure out ways to reduce energy consumption by reducing the sensors that are used. So some were energy intensive. So the question is, could you use some of the others to do its job? And this was done while he was undergrad. And so this, for instance, would have helped with his applications to grad school. This is by Keanu, another undergrad. Well, he did this when he was an undergrad. He wanted to do something in satellite imagery, and so we came up with this idea of computed deforestation rate. This is another TSTT-based paper. So TSTT has this way of getting feedback from consumers about how well they are doing, but it doesn't provide sufficient information to capture root cause, the specifics of problems being faced by individuals. So we came up with this different approach to taking surveys. We ran the survey for two providers, TSTT and Digicel. But the approach is, it's a nice trade-off between consumers actually doing the survey, because I, for instance, don't do a survey if it's going to take me more than 5 minutes. So I don't want lots of questions, but to get specifics about the pain points of a customer, you need to ask detailed questions. So this allows you to do that. There's another one. This is marketing channel recommendations in banking. So this was done for the CIBC project. It collaborated with Nigel. Nigel is actually now a data scientist at Microsoft. He used to be at CIBC. All right, this is a material and cost estimation of a customized product based on customer's description. So this is an idea that Kevin came up with in his job at TYE. His background is mechanical engineering, but he was able to learn whatever he needed to learn to do this particular project, and they actually use it within the company. Yeah, so he should be starting his PhD as well. All right, so anomaly detection of marine seismic signatures using semi-supervised learning. This is a problem that Gregory came up with based on his job, and he used it for his MSc thesis. All right, prediction of automobile insurance claims, personalized versus confidence trade-off. So this is something I worked on when I was, doing stuff with Beacon. Because again, you asked the question was, well, they would ask, if you want to provide personalized insurance, how personalized can it be? And well, of course, that depends on the number of customers you have, right? If you have 5 million customers, then you can make it very personalized. So the question is, how best do you trade off between robustness of the estimate and sample size? So this is how that came about. And actually, Chris is applying the same approach for another problem we're looking at. Using chatbot technologies to help individuals make sound personalized decisions. So this is work by Rishon, again, based on stuff we did at CIBC, but it's something they didn't use because again, it would have taken quite a while to deploy this or come up with a commercial grade product for it, and with a 6-month period to do it, the project. Well, first of all, it wasn't even 6 months. It took us about 3 months to get permissions because of the bureaucratic issues we had. So we had a very short time frame, so we couldn't finish this. But we did put together a paper with Nigel. So this could be considered, societal impact work as well. It was a humanitarian technology conference. Premium rate services fraud detection. So this is Mariella, together with Richard Roach at TSTT. So this is a TSTT problem. So Mariella is now at Guardian. This is another project from TSTT done by Navin, and Zahira was the counterpart at TSTT on upselling telecommunications products. Instant message summarization with emoji, Unicode, character set support. This is Darren. So this has been around for a while. This started back when Nicholas was working on his sensor stuff, body sensor stuff, and he wanted some way to condense SMS messages to fit on a smaller set of pixels. So Darren took up that challenge and produced this journal paper. So again, this is a collaboration with an external company, not only internally, we do work, we do external work as well. This is another, yeah, so Nicholas used to get a lot of free help from us. This is another journal paper, but on dynamic group formation in an online social network. So this was developed for a new startup he's working on called Venzi. And this is on, social networking stuff. Also collaboration on this was UC Davis, which is Andre Newson, who is his supervisor. Estimated carbon content of oceans using satellite sensor data. So this was proposed by ADIDEV. We brainstormed what we could use that satellite data for, and we came up with this. And it's I believe it's accepted, but we don't know when it will be coming out. But this was some interesting work as well. And yeah, and again, this is climate change type stuff, so which is becoming more and more important in terms of research. All right, optimal stopping criteria for customer contact strategy in targeted marketing. So this was initiated by Shiva. We had a conference paper, then we have this upcoming journal paper. So Shiva identified, was able to get this bank data set, and we worked on this particular problem. So, normally I would say, stay away from public data sets because they are overused. You have data scientists all over the world working on them, so it's hard to come up with something different or novel. But in this particular case, we were able to identify a problem that nobody really looked at. They used the data set for other things, but they did never use it for this particular problem. And so because it was a unique problem, we were able to come up with a nice solution for it. All right, so yeah, I guess that's it. So locally, yeah, and regionally, we need to develop data scientists so they could solve real world problems using the most advanced technologies available. The model we use in TT Lab can create this pipeline of data scientists. And now, other people have asked me to kind of replicate this in a way. At one time, UE asked me to bring in TT Lab into UE, but the question was, how would we be able to have the speed of execution we have as we do right now, without all the bureaucratic stuff. TTI IFC, Trinidad and Tobago International Financial Center, asked me at one time if we could do something like that. They were training people with Tableau in data science, but of course that wouldn't get you to the point where the person could go into a company and take a data set and identify a problem and formulate that problem with data science solution. So they had asked me about doing this as well, but they had no funds to do it. so yeah, it works, but it needs, some sort of funding. And of course, once that funding comes in, then I think there's a possibility to create revenue that would offset that funding. But maybe some of you might be able to take it to that stage later on. All right, the one of the reasons too for doing this is to retain talent locally. I always tell people, do whatever is best for your particular situation. But I know many people, if they had challenge in work, if they had flexibility in execution of that work, if they were compensated well, then they have no issues in staying locally and working, right? And that's it. So let me stop sharing here. All right, so we still have so yeah, so that is TT Lab in a nutshell. That's the objective. The hope is that it could be continued. Of course, I will continue working on it for as long as I can. I am doing this remotely, so even when I will be going on sabbatical from September, but even on sabbatical, I will, in fact, when I am on sabbatical, I'll probably have even more time to spend on research. So I'm hoping to ramp things up. I just need to figure out what else we should be doing to increase participation, because sometimes I get the feeling that people are not as interested in doing research, and I'm doing research is a personal thing. Some people like it, some people don't. So if you don't like research, if you don't like solving a problem, or coming up with a solution that is unique, then research, it may not be for you. So just keep that in mind. But yeah, in terms of future of TT Lab, I will continue as is. If we get funding through ICAMP, for instance, to support some interns, that would allow us to have more interns in companies, because companies would jump at the opportunity to get a basically free intern solving their problems. And I guess that's it. I'm trying to see what I should make notes, trying to see what else I need to discuss. Yeah, and I know it's hard sometimes getting a problem for some of you. I have been working with some of you trying to identify problems. What I try to do is match your background, your expertise with your interest. And sometimes coming up with a problem, combining those two things is not that easy. I mean, I could throw out problems for people, but I don't want to do that. Which is why, if when people come to me to do a thesis, MSc thesis, I say, you have to help me find, you have to identify a problem to solve. I am not going to give one. Sometimes I assign problems to people because I have something interesting, and they may be interested in that. So if I'm working on something that I know a particular individual would be interested in working on that, I would say, look, work on this problem together with me. But with such various backgrounds, it's not that always that easy to find a problem. But you know, I'll continue doing that. But the thing I want to emphasize is if you know if you want to be in TT Lab, then yeah, you have to put an effort into doing something, right? And we always look forward to having alumni as well, you know, help us. So okay, so that's about it for me. I am going to open it up for any kind of discussion you all want to have about oh yeah, so instructor raised hand. Didn't realize it was Nicholas. Yeah, Nicholas, yeah, go ahead.
Hi, good evening, everyone. So I think it's a real good thing good timing that I saw this because I'm going to talk with a bunch of final year students soon. So trying to make sure and let them know the kind of opportunities they have. So if I understand, the pipeline would be for them to pursue some MSc degree, whether it's data science or comp sci, or it should just really be comp sci. I'm sorry, data science if they're looking to get into the internships and whatnot.
Oh, anybody. And as I said, you know, sometimes I do take undergrads, people now graduating, for instance, but you know, they have to be serious. I don't want people just joining because you know they want to be part of it. But yeah, it could be, you know,
So they could be graduate as long as they demonstrating this skill.
Yeah, so they may have to pick up on certain deficiencies, you know, if their background doesn't have data science, you know. But you know, like for instance, Nirvan did his MSc in computer science, Rishon did his in computer science, you know, and they picked up whatever they needed to pick up for data science. So we have people here, Akshay is in electrical, Daniel comes from, well, no, he's doing MSc in data science now. Vishan is electrical. So yeah, the background doesn't matter, but you know, what matters is I need to understand their background and be able to find something that they would be able to achieve within a short period of time. So that's normally the challenge, you know, finding. Luckily, I have a background in electrical, so that isn't too difficult sometimes, but in other things, yes.
And then I also hear that you mentioned like a faculty person. They should be like an instructor or higher.
Well, okay, so that was the model, and the question is if you will get people to do what I do for free, right? But yeah, anybody who can help the student identify the problem, formulate it into put it into a form that the student would recognize as something they've looked at in the past. So, and this varies across the board because remember we're looking at different domains. So if we're in insurance, they have to understand the terminology in insurance. They have to understand the objectives. So yeah, so the background would help me determine where to place them. And but yeah, but it could be any background. As I said, you know, like for instance, I know Jamie was here. Jamie's in physics and she's doing quantum computing stuff. So yeah, we've had people from mechanical. Well, yeah, Kevin is in mechanical. So yeah, the background is what all you really need to do good research is to have the hunger to learn and you know be willing to sacrifice. Well, I shouldn't say sacrifice, but be willing to do the hard work to learn what you need to learn for that particular problem.
Okay, so that this supervisor person, they would so they should be like I'm trying to figure out how do you know when how would someone move from that intern position to where you realize that they could probably supervise other interns.
Well, yeah, so you know I know people here in this session here, for instance, there are people who can do that, but it takes time. So, you know, for instance, you know, Inzamam wouldn't have the time to do that, you know, etc. Now, from within the department, there are people as well. You know, I'm sure Phaedra could do some of this, etc. But as I said, you know, the model would have to include some kind of compensation for that person, that staff member. But I would say, you know, people like you, Nicholas, who supervised projects, etc., would be able to do this kind of stuff as well.
Yeah, I just have to lean in some probability, but then, so what was my other question? Yeah, so how the CCU does it with like the software engineering projects, the kind of websites and stuff, and web apps. There's always a budget made every time a contract is drafted for development or maintenance. They seem as two different things. And in the budget, there is an allocation that goes to the department, the project manager, whoever is the project manager, and of course to the students as well. But the cool thing is, as a project manager, you can manage multiple projects, even though from that one particular contract, it won't be anything substantial. If you scale it out, you could, you know, these things kind of add up. So that was the kind of idea behind that setup.
Right, and I think yeah, something like that will work, you know. But to be honest, I don't have the don't have the patience to do that. Yeah, that route. Right now, it's simple. You know, for instance, if a company calls me today and says, all right, they need 5 interns, I give them 5 interns within a few days, and then within a week, we start doing work, right? You know, within UE, and I understand the reason, you know, it will take a lot longer because, you know, you have to formulate, you have to have the MOU, etc. You have to get it approved, signed, all that kind of stuff. So I'm not saying it's not, you know, we shouldn't go that route. I'm saying in my particular case where I prefer speed and agility, yeah, I prefer, you know, have it done this way right now.
Okay. And then finally, for the kind of people who would work with the div solutions, you say they would be like full-time, or they're like part-time now?
Right now it's part-time, like Jordan is doing part-time work. Hopefully in the future, as they get more jobs, you know, they may be able to hire full-time people. I believe recently I saw Eddie advertise a remote job in Canada. Yeah, so some of those things as well.
Good job.
But yeah, but the thing with Div is we have the ability to publish as well, but you know, it's more of a commercial entity as opposed to a research entity. So the focus is really getting the job done for the and long-term maintenance of the whatever product we develop.
And these students will have like the similar background as like somebody coming in as a TT lab intern, right? It could be like a post student.
Yeah. So right now, Jordan, he and Nicholas actually came to me a couple of years ago. So they are mathematics. They came to me and said, well, they're in mathematics, but they want to see if they could do any research. And so he himself had to well, actually, I keep saying Nicholas is doing the Georgia Tech degree. It's actually Jordan. Jordan is doing MSc in data science at Georgia Tech. So yeah, so he comes from a math background, but he had to pick up data science. So again, it really, the background isn't as important as the
motivation,
the hunger, the willingness to do whatever it takes to learn. So I've had people with very little data science background do excellent work, and I have had people with data science backgrounds just do average work, so it really depends.
Okay, all right. Thanks. I'll try to communicate this to these students.
Yeah, please do. I want to encourage undergrads more to do research, but I think some of them, they're not sure what it is about, and they don't see it as necessary for their jobs, etc. So I think they focus more on doing whatever it takes to get a job. So, okay. Any other questions or concerns about TT Lab? I mean, as I said, future will be similar to what it is right now. Have no plans to expand. The only difference might be, we kind of focus more on journal type stuff. Would be nice to file some patents, but that is a little bit difficult without buy-in from industry. So to be honest, I mean, things we've done in industry, I think have potential to be patented, but it would have been difficult to do it. So, for instance, the only patent we've done is the one with Ramnik in Korea, and the reason I did it with her in Korea is because it was recognized to be something of value, and the university went through the process. So I don't know how to put this mildly, but the things we call innovation is not really innovation, and any things that are really innovative, we locally don't appreciate it. So yeah, that's a big issue we have. All right, anything else? Any questions from the new people about how we structure things? And I know some of you would like to become interns, and yeah, as soon as things open up, with COVID, a lot of the opportunities for internships kind of died, but hopefully with time things start picking back up, and there's a bigger emphasis now on data science. Companies are beginning to recognize the value, and also cybersecurity is another main area people are worried about. We haven't done much in cybersecurity except for the stuff that Rishon did on the honeypot, and the stuff Darren did on intrusion detection. But even those things, which to me, it would be nice to take further along, but because of time, we didn't do that. But so this USAID, that's the talk I'm going to give in the cybersecurity event is on that stuff, because they actually were interested in the stuff that Rishon did on honeypots and the stuff Darren did on intrusion detection. The title of the talk they wanted to, the panel they wanted to have is on low-cost solutions, which is basically what we have. The stuff Darren did was very low cost, very simple, but it did the job. It did a good job. It's not perfect, but it did the job. So yeah, cybersecurity, of course, things like 5G, IoT is important as well, but we cannot do as much in those areas as we could with data science.